Hey guys, welcome to part 4 of the volume series. This is the last and final part. We're going to talk about Cavalieri's principle. So Cavalieri's principle essentially states that we can twist shapes and it does not matter. The shape still will maintain its volume or the space it displaces. So we're still going to be relying on the essential volume formulas here, as we will throughout any time we're working with 3D shapes. So Cavalieri's principle states that no matter what, these objects will take up the same amount of space, regardless if they are slanted, twisted, or deformed. And this is essentially helpful when we get into the realm of calculus and other forms, when we start dealing with non-Euclidean geometry and we start worrying about things that aren't nicely perpendicular. We have to start applying tools that we have to manipulate our situation in our favor so that we can get to the answers we need to get to. We can't limit ourselves to being a perfect world. And that's essentially what these problems do for us. We have to learn to work around imperfections. So let's start with a couple of things here. I brought this up before. This is a prism, and we cannot use this 15 centimeters as the height, called the slant height. This is not a perpendicular side, so we cannot use this. We have to find this here. And the only way we could do that is by invoking trig. We're going to have to use trigonometry. So now if this is 15 centimeters, so is this. And I am going to label my triangle. If you are unsure, you can search the interweb on videos on how to perform right triangle trigonometry, or you could watch my video and review right triangle trigonometry, which is probably one of the more powerful maths we cover in high school. Now, here I need the opposite, and I have that hypotenuse, so I'm going to use sine theta, which is equal to O over H. Plug that in. And we have, I guess I'll call that X for now. Sometimes I like to put an H there to make sure I remember what I'm looking for. I'm going to cross multiply. So this is X equals 15 times sine. And now I'm going to ask my calculator what the answer is. And the answer is 15 square root 3 over 2. Now that looks like a nightmare, but I've mentioned this before. Oftentimes we get intimidated by square roots and fractions, but they're designed to make life easier if you know the rules. The other thing I want to mention before I move forward and actually finding the volume of the prism is that I stress in all of my videos just using operations and knowing how things work as opposed to memorizing, and that is why I cross multiplied using trigonometry. Now let's find the volume of this prism. So the idea of any 3D shape is to just find or multiply 3 dimensions that are perpendicular to each other. So we arbitrarily label these sides length, width, and height. I don't particularly care for that because if we twist things around, it becomes difficult to tell which dimension is which. So let's not fixate on that. All we want to know is we have to multiply 3 sides together that are perpendicular. Perpendicular means right angles. So what we have done is we have created a height here, or in better terms, found a height. So I found a perpendicular length to this base here, which is this crazy number of 15 square root 3 over 2. I now have 3 perpendicular sides. I can now multiply everything together. So let's just do that. So I have 3 times 3 times 15 square root 3 over 2. Another thing I want to bring up here that's really important as we talk through these volume formulas In this particular case, it does not matter which order I punched or substituted these numbers in for, these values, because we're multiplying. So I could have placed them in any order I would have liked. I just arbitrarily chose to do 3 times 3 times 15 squared root 3 over 2. I could have put the 15 squared root 3 over 2 in the middle or in the front. It would not have mattered because we are multiplying. So now I could actually do this by hand, I think, because 9 times 15 square root 3 over 2. 9 times 15 will be 135. I double checked that with my calculator. So I have 135 square root 3 over 2. Done. Nice, simple answer. I'm going to put the unit at the end. In the previous video I bring up, and this takes a little bit of play on the student's part or the learner's part, is when to use the calculator, when to do things by hand. It takes a little bit of experience and a little bit of trial and error. The thing I think that I would love for you to take away is that decimals typically force a calculator. If you want to work decimals by hand, you surely can, but it becomes less efficient than using square roots and fractions. The issue with that is the rules for decimals tend to be a whole lot simpler than the rules for fractions, so there's a trade-off, right? But if you can know the rules and understand how fractions and symbols and radicals work, you can actually move more efficiently. Alright, let's go to the next problem. In this problem, we're looking at a cylinder that is twisted to the side or pushed over. I'm going to invoke the volume of a cylinder. But, once again, we have the slant height, so that is not perpendicular. So I need to find the actual height here and create like a perpendicular situation. Kind of like that. That's what we want. I have a couple of choices here. They were very nice and they already gave me the radius, so that's really nice. That is right here. So I'm going to plug that into the formula. It's down. Then I have to figure out how I'm going to find the height. So this diagram was very nice and they drew this triangle for me. I think what I'm going to do is Pythagorean theorem. So when we use Pythagorean theorem, I'll write that up over here. Typically known as a squared b squared equals c squared. And what we're going to do is we're going to label our legs and our hypotenuse. Now I prefer to always label my hypotenuse first. I believe I also have a video on Pythagorean theorem. Or, I guess, like I said, you don't have to stick with my videos. You could always go search the interweb and see what's out there. Then from there, I'm going to label my legs. It does not matter how I label them, so I'm going to just label A and B that way. And now I'm going to plug in 13 squared. Then I have 5 squared. Squared. I have to square everything as I run out of room, so I'm going to have 25 equals 169 plus a squared. And I'm hoping that the colors are helping you understand how I am substituting. Now I am going to subtract the 25. So I have 4, it's a squared, then I have to square it. So I am going to square root square. I'm going to get 12. So that is my height, 12. I'm now plugging that into my formula. Okay, so let's see what we got here. Well, 10 squared is 100. I just brought down the equation around it, and now we have 100 times 12, which is 1200 pi. Worked out rather nicely. Nice clean numbers. I think if we would have used trig, we would have had to have done a little bit of rounding. I don't mind taking 15 seconds just to show you guys if I would have used cosine. So let's take a look at that. So let's call this a side note. So I'm going to label my triangle. So this is O, H, and A. I'm going to have to use sine. I think I might have said cosine. We're going to use sine of theta to do this. And that's going to be O over H. So we're going to plug that in. Sine of theta. 1 is, let's say, x over 13. I'm going to cross multiply. I should put the 67. I'm moving rather quickly here, guys, to get this done. So now this is 13 times sine 67 equals x. And x equals 11.96, which you would likely round to 12. To my point, when we work through math, we have to learn to find our way to solve these problems. There is no wrong way. Your answer would have been slightly different than, let's say, if I would use Pythagorean theorem if you didn't recognize to just round up to 12. But that's the point of working through these problems, is to getting experience and finding your path to learning and being successful at this topic or this discipline, which is quite huge. Alright, let's go to our next example and our last example. So these require a lot of problem solving here, so let's take a look at a couple of things here. I have 3 shapes. I have a cone, I have a cylinder, and I have a hemisphere. So let's start working through this. The volume of a cone is 1/3 pi r squared times height. Then the volume of a sphere is pi r squared times h. Then you have the volume of a cone. Now there's a couple of tricks here, and one is you could divide the volume of the cone now, or you could do it later. If you wanted to do it now, I don't mind showing you that. We multiply this by 1/2. That creates 4 over 6. And then the rest of the formula goes with it. The only thing the 1/2 can multiply is the 4/3 because that's the only number. Now, the 4 over 6 reduces to 2 over 3. And then I bring the rest of it around it. It's entirely up to you. You'll get this answer either way. But let's figure out the next part. So I have the radius of everything because they gave me the diameter. The diameter is here, which is 6. So I need the radius. So r is going to be 3. Or, if this helps, 6 divided by 2 is 3. And that's how I got that number, because the radius is half the diameter. So I can now plug that in everywhere. 3, 3, 3. And now I have to start finding some heights. So let's take a look at that. Well, the height of the cone isn't that bad. It's right here. So that would be 5. So the trick now is the height of the cylinder. So let's take a look at that radius. So a radius can go in any direction inside a sphere. That's the point of it. So we could go this way, we can go that way, we can go that way, we can go all the way around, or we could even start to go up, and then that will become 3. When we do that, this here is 3. Then we know that this height here is 5, which 3 plus 5 is 8, and 8 minus is 8. So 5 plus 3 is 8. 8 minus 16 is 8. Take a second to understand how I figured all of this out. The key is to understanding that the radius can go in any direction in a sphere. So now I have these. Okay. So that's 8. Well, we could do a lot of this by hand, so let's do that. This here is 9 times 5, and then bring down the 1/3 pi. So now 1/3 times 9 is 3 pi times 5. So that's going to give me 15 pi because 3 times 5 is 15. This is 9, because 3 squared is 9, times 8, the pi. This is going to give me 72 pi. Now comes the last one. 3 cubed is 27. Here what I have to do is I have to multiply 27 by 2/3. This is where fractions become easier, because nothing says that I have to multiply before I divide. So I know that 27 divided by 3 is 9. I'm actually going to write this out. Hopefully it doesn't confuse anybody. So 27 divided by 3 is 9. So now I have 2 times pi times 9. Now I'm going to get 2 times 9, which is 18 pi. I could have done this either way. I could have said 27 times 2 is, let's see, 54. Then 54 divided by 3 is 18. I could have done that either way. It does not matter. So here, those are your choices. Just, again, play with this stuff as you figure it out. That's where math actually becomes kind of fun and a little bit less tedious. Alright, now, all I have to do from here is add everything together. So I'm adding everything together, and I am getting 105 pi. That's that. So that's the end of the solving 3D shapes. For now, anyway. I hope you guys found this series of videos helpful.